Algebra 2, Lesson 10-2, page 505. So number 1, it says graph the function f of x equals the square root of x and g of x equals negative the square root of x on the same grid. Describe the domain, range, and end behavior of each function. All right, so let's see here. I'm going to scoot it up a little bit. There we go. So f of x equals the square root of x. So what if we put a 1 in there? What's this? The square root of 1? That would equal 1. So x is 1, y is 1. There we go. All right. And then let's put in a 4. What's the square root of 4? Well, the square root of 4 is 2. So let's go to 4 and then 1, 2. All right. So and we get the pattern. So it's going to look something like this right here. All right. And then let's do g of x equals negative the square root of x. All right, let's try 0. Negative the square root of 0, well, that would just equal 0. So we got 0. And then what if we put in a 1? Well, the square root of 1 is 1, and that would give you negative 1. So 1 and negative 1 would be right there. And, well, let's put in a 4. And that would give you negative 2. So 4 and then negative 2. There we go. And it looks something like this right here. All right. So what do we got? If you'll notice, g of x is f of x reflected over the x-axis. All right. So I'm going to erase this right here. So what is the domain? The domain, well, let me do it like that. Domain. And then I'm going to put f of x here, and I'm going to put g of x here. All right, so what's the domain for f of x? Well, it's going to be x such that x is greater than or equal to 0. All right. Well, what about for g of x? It's the same thing. It's going to be x such that x is greater than or equal to 0. Now, why can't it be less than 0? Well, think about it. F of x and, is the square root of x. Well, if you put negative 1 in there, you get what? You get a non-real number. Okay, so we can't do that. Well, let's check out the range. That was the second thing we were supposed to check on. So what's the range? Well, let's see. It starts here at 0. We got y such that y is greater than or equal to 0. Okay. Eventually, it's going to get way up here. It's going to be way out there before it does, but it's going to get further to the right than it does high, but it will get there. What about g of x? Well, g of x, that's going to be y such that y is less than or equal to 0. Because it's getting down here, right? What about the end behavior? The end behavior. Let's take a look at it. As x approaches positive infinity, f of x, f of x approaches positive infinity. And what about over here? As x approaches positive infinity, g of x approaches, and it's getting down, so we're going to say negative infinity. We good? So how are the functions related? Well, as I said earlier, they are reflections of each other. They are reflections of each other over the x-axis. All right, good. Well, let's see here. Number 2, 3, and 4. It says, describe the transition of g of x from the parent function f of x. Okay, well, let's see here. I think first be good time for a few notes. So let's put some notes up there. At this level, we're going to show you two ways. We'll say g of x equals a times the square root of x minus h plus k. Or you might see it as g of x equals the square root of 1 over b times x minus h plus k. All right, so the a, like always, is a vertical stretch or compression over the x-axis, vertical stretch or compression by a factor of whatever a is, or reflect, it could be and or reflect over the x-axis. Now B here, B is going to be a horizontal stretch or compression. And or reflect over the y-axis. Okay. H will be a horizontal translation left or right. And then K will be a vertical translation. Up or down. And let's do a couple examples. So let's put in here the square root of x. All right, and there it is. What if we, let's see, we'll use 4 times the square root of x. This should be a vertical stretch by a factor of 4. Boom, see how that pulled it up? What if instead of 4, we did, we'll say 1 over 4. 1, control, divide, 4. Make that 1/4. And then that should be a vertical compression. Okay? Now, let's see here. Let's go back in there. Control, delete. And we got the square root. And we'll say x minus 2. Notice how that moved it 2 units to the right. All right. What if we did x plus 2? That moves it 2 units to the left. All right. And then the square root of x. And then we'll put in plus 3. And notice this will move it up 3 units. Notice we went from here to 1, 2, 3. And what if we change that to minus 3? And notice how that moves it down 3 units. Okay, so that's how the different positions, A and H and K. What I haven't done yet is B. So let's try B. So we're going to put in the square root. Oh. All right, let's put in control square root, and we'll put in 2. Well, we've got to put in the x first. Let's put in the x. Okay, now let's see, tab, we'll put in the square root of 2x. Now, in this case, b is 1/2, so that's going to be a horizontal compression. Let's see how it kind of pushes it. All right. And then what if we change that to 1/2? Let's see here. 1, control, divide 2, 1/2 x. So that should be a horizontal stretch. And there you go. Okay. So that's the different ones. Let's take a look here. All right, describe the transformation of g of x from the parent function f of x equals. So we got 1/2 x plus 1. So we're going to have b equals not 1/2 but 2. Remember, this is 1 over b equals 1 over 2. So do a little cross multiplying and you get b equals 2. What that's going to be is a horizontal stretch by a factor of 2. And we're going to have k equals 1, and that's going to be a vertical translation up 1 unit. And we can test that out on our calculator. One half x, and so I just got to put plus 1. That worked out real well. And see what it did. It moved it up 1 and stretched it out. -5 times the square root of x plus 1 minus 3. So now we got a equals -5. A equals -5. And that's going to be a vertical stretch by a factor of 5. And reflect over the x-axis. We're also going to have, well, h equals -1, so that's going to be a vertical translation. Left 1 unit, and I know what you're thinking. Yeah, well, that Mr. Carr, that's +1. Well, remember what we had here. It should be inside of there should be x minus h equals, and then we got x plus 1, right? Subtract x from both sides, and you got -h equals 1, so h equals -1. All right? And then the last thing we got is k equals -3. K equals -3. And this is going to, oh, I said a vertical translation. That should have been horizontal. Horizontal. We're going to have a vertical translation down 3 units. All right. And let's graph that and take a look at it. So we're going to tab, and let's see, Control Delete, and we've got -5 times the square root of x plus 1, and then we got -3, I believe. -3. Notice how I got it outside of the thing there? Let's see. Did it do everything? Well, let's see. It reflected it over the x-axis. It stretched it by a factor of 5. It horizontally moved it left 1 unit, and it also vertically moved it down 1, 2, 3 units. So yes, it did in fact do everything. Here we go. Number 4. So we've got a equals 1/4. We have h equals 5, and we have k equals 2. And I would like you to describe what each one of those are. All right? Number 5, I'll give you a hint. b equals -1/7. Okay? I want you to tell me what position that one's in, and I want you to describe what effect each of these has. If you need to, you're welcome to use a calculator to test it as you go. Number 6, it says describe the domain and range of each function using set notation. All right, so what do we know? Well, let's see. Let's take this, what's inside of here, and we've got 1/3 x minus 1. And remember, when we did all of them was greater than or equal to 0. So we're going to put greater than or equal to 0. All right. We're going to multiply both sides by 3, and that gives us x minus 1 is greater than or equal to 0. All right, 3 times 0 is 0. We're going to add 1 to both sides, and we got x is greater than or equal to 1. So our domain, our domain is going to be x such that x is greater than or equal to 1. All right. What about the range? Well, let's put the range up there. And we're going to have the square root of 1/3 times x minus 1 is greater than or equal to 0. Well, we square it, and we got 1/3 times x minus 1 is greater than or equal to 0. Well, we multiply both sides by 3, and we got x minus 1 is greater than or equal to 0. Actually, that's not working out quite right. What do we know? What do we know? There is no k here, right? Or you might say it's plus 0. So the range, this is the domain. The range is just going to be y such that y is greater than or equal to 0. Okay, because there is no k. Over here, what do we see? Domain, I guess we could do this x plus 4 is greater, what's inside of there. But what do we know? Well, we know that h equals negative 4. So the domain is going to be x such that x is greater than or equal to negative 4. All right. And we know that k equals 3. So the range is going to be y such that y is greater than or equal to 3. Now, notice that a here is positive. A was positive there, so it's greater than. Okay? Now we're going to get down here, and a is, or b is negative. Okay? That's going to change stuff up. What do we got here? Well, h equals negative 1. But since this is a negative, it's going to reflect over the y-axis. So our domain is going to be x such that x is greater than or equal to negative 1. Oh, less than. I'm sorry. It's got the negative. It's going to be less than or equal to negative 1. And we can do this algebraically. We got negative 5 times x plus 1 is greater than or equal to 0. Well, multiply both sides by negative 5, and that's going to give you x plus 1. Since you multiply by a negative, that's going to be less than or equal to 0. Subtract 1, so x is less than or equal to negative 1. That's algebraically. Now, we got 2 here. A is positive, so k equals 2. A is positive, so the range is going to be y such that y is greater than or equal to 2. All right. Here, no b, or b is 1, so we've got h equals 3, so our domain is going to be x such that x is greater than or equal to 3. K is negative 5, but notice a is negative here. A is negative there, so our range is going to be y such that y is less than or equal to negative 5. Okay, and that's because that is negative. We good? All right. It says plot the transform function g of x on the grid with the parent function f of x equals the square root of x. Describe the domain and range of each function using set notation. So we've got negative x plus 3. Well, what do we know? Well, k is 3, so that's going to move it up 3. 1, 2, 1, 2, 3. That's going to be right there. Okay? And we also know that it's going to slope down because a is negative 1. All right, let's just try it. Let's put a 1 in there. What's the square root of 1? 1. So we got negative 1 plus 3. That's going to give us 2. So we're going to have a point here at 2. Okay? And we can, well, 4 over here. What's the square root of 4? The square root of 4 is 2. So we got negative 2 plus 3. That gives you 1. So that's going to be right there. So it's going to look something like this right here. All right. So the domain is going to be x such that x is greater than or equal to 0. And the range, and that's because h is 0, the range is going to be y such that y, since it's negative, it's going to be less than or equal to, and k is 3. We good? All right, let's look over here. Now this is going to be a little bit different. Well, we're going to go down 1. We're going to go left 4. 1, 2, 3, 4, right there. Okay. So we got to be careful. Let's let x equal 2. So we put a 2 in there. 2 plus 4 is 6. 1/3 times 6 is 2. I don't think I want to use that. That's going to be because that's going to be the square root of 2. I need to pick something that will give me, well, put a 0. No, that's going to give you 4/3, the square root of 4/3. That's going to be tough. We know it's positive, and that's 1/3. Put a 3, and that's going to be 7. Put a 2, and that's going to be 6. And that's 0 gives you 4, and it's 4/3. What if we put -1 in there? -1, and that would give you 3. 1/3 times 3 is 1. The square root of 1 is 1. 1 minus 1 is 0. All right, so we found that. That's all we need. And that gives us to it. Sometimes you got to think about it a little bit. All right, to pick the right number. So what do we got? Our domain, since h is -4, our domain is going to be x such that x is greater than or equal to -4. And our range, since k is -1 and a is positive, our range is going to be y such that y is greater than or equal to -1. All right. Let's try number 12. Whoa! There it is. There's number 12. Sometimes this thing gets away from you. So number 12, what do we got? Well, we have b is -2/3, so let's see, we're going to go down 2, down 1, down 2, all right, and we're going to go right 1/2. That's going to be right there. Okay, that's going to be right there. Now we got to pick a number. Pick a number. Well, let's try -1. Minus that's negative. Let's see. We'll put -1 in there. So we got -2/3 times. Well, that would be -2/2. That's -1 minus 1/2. That's going to be -3/2. -3/2. And square root, and then -2. So -2/3 times, that's going to be +1. The square root of 1 minus 2 is 1. Okay, so that's going to equal 1. So we've got -1. Well, 1 minus 2 is -1. There we go. And then here is our graph. Okay, now that gives us our domain. This is negative, right? All right, and then and h is 1/2, so we're going to have x such that x is less than or equal to 1/2. Okay, and that jives with our thing here because here's -1/2 is right there, and it goes that way, so it's less than or equal to. Range, a is positive again, so it's going to be y such that y is greater than or equal to, because a is positive, and then we got -2. And that jobs with our graph. Goes right with it. Okay, so what do we got here? We got k equals -4. We have h equals -3, and we got a equals 4. B is 1, of course. So what do we got? Well, let's see here. We're going to go left 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. Okay. And if we put 1 in there, 1 plus, so we're going to do x equals 1. 1 plus 3 is 4. The square root of 4 is 2. 2 times 4 is 8, minus 4 is 4. So we got 1 and there it is, 1 and 4. So it's going to look something like this right here. All right, and we have our domain. B is positive, and that's h is -3, so we're going to have x such that x is greater than or equal to -3, and that, and that jives, because it's here and go. And then our range is going to be y such that y is greater than or equal to, and we got -4. And that's right with that. There we go. Now it doesn't want to, oh, there it is. Uh-oh. Write the function that matches the graph using the indicated transformation format. Okay, well, what do we know? What do we know? Well, this point here, that gives us our h and k. That gives us our h and our k. And let's see, so that is 1 and 1. 1 and 1, right? Okay. So we've got part of it. G of x equals the square root, and we got 1 over b, and then what do we got? We got x minus 1, and then we got out here we got plus 1. So we need to find out what b is here. Well, it's got a point here. It's got this point here will help us. That is 1/2 and 2, right? 1/2 and 2. So this is our x and that is our y. So we got 2 equals the square root of 1 over b, and then we've got 1/2 minus 1 plus 1. Well, let's subtract 1 from both sides, and we got 1 equals the square root of 1 over b times, and that's going to be -1/2. Okay. We square both sides, we still get 1 equals, that's going to be -1/2 times 1 over b. Well, let's see here. If we multiply both sides by -2, we get -2 equals 1 over b. And then do a little bit of a trick, do a little bit of arithmetic, and we get -1/2 equals 1 over b. Okay? And, well, let me show you how you do that. How do we do that? We multiply both sides by b, and we get -2b equals 1. And we divide both sides by b, and we get -2 equals 1 over b. Let's see here. How did we got -2. Multiply both sides by b. We got -2b equals, oh, I'm sorry. That was 1 over b. I want to divide both sides by -2, and we get -1/2. All right, b equals -1/2. So our equation, g of x equals the square root of -1/2 times x minus 1, and then plus 1. Plus 1. And we can graph that. Let's graph that. Let's see if that worked. On, new, no, graphs. And let's see here. What do we got? No, b is, that's supposed to be 1 over b, which is what we had over here, right? So that makes that negative 2, negative 2. That's what we're looking for. I don't know why I took it further. All right, we don't need all that. That's what we need to put in front of the x here. Okay, so we got the square root of negative 2 times, and open parentheses, x minus 1, and then plus 1. And see if that, and that looks like it, doesn't it? All right. What about this one here? Well, that tells us a lot right there. We got negative 3, 0. So there's our h and our k. That's negative 3, and that's 0. Okay. And then we got this point, negative 1, 1, negative 1, 1. And we can kind of put that in there. Let me see here. I need some real estate. So let's do that. We've got g of x equals the square root of 1 over b times x plus 3. X minus negative 3 is x plus 3 plus 0, so we can leave that. Now let's see here. We're going to put, for the y, we got the 1, put the 1 there. For the x, let's put negative 1. So that's going to be negative 1 minus plus 3, minus negative 3 plus 3. Okay, so we got 1 equals the square root of 1 over b times, well, that's 2. All right, square both sides, and I'll just show it. I didn't show it last time. Let me show it this time. Square both sides. And we've got 1 equals 1 over b times 2. Divide both sides by 2, and we got 1/2 equals 1 over b. All right, now we've got it. So we have our equation. G of x equals the square root of 1/2 times x plus 3. And we don't have to worry about the k because the k is 0. I guess you could write 0, but you don't necessarily have to. And let's try 16 and 17. What do we got? Let's see here. We got this point right here. That's negative 1, and then let's see. 1, 2, 3, 4, 5. Negative 5. So h is negative 1, k is negative 5. All right. And so we've got g of x equals a times the square root of x minus negative 1, or x plus 1, and then minus 5. And then we've got this point here, and that looks to be 0, 2. 0, 2. So we'll put the 2 in. We got 2 equals a times the square root of, and then we'll put the 0 in for the x, 0 plus 1, plus 1, and then minus 5. All right, so I'm going to add 5 to both sides, and I get 7 equals a times the square root of 1. That's 0 and 2, yeah, and then add 5, that gives me 7. Okay, and 0 plus 1. Minus, I had 5, I got 7, and square root of 1. So 7 equals A. So my equation, g of x equals, and it looks to be, that was -5. So that's -5. I got -5, so I added 5. Yeah, that looks right. 7 times the square root of x plus 1. Oh, yeah, x plus 1 minus 5. Let's graph that. That's not, I'm not so sure about that. No. Let's graph that. Graph. We got 7 times the square root of x plus 1 and then minus 5. Oh, didn't get it outside there. Minus 5. All right. That doesn't look right because that's going way up there, right? So what do we got here? So g of x, 2 there. What is this? This is 0, -2. So that's -2. There's where it is. So that should have been 3. And that would make that 3. So that makes that a 3. And then, oh, look at there. See what them negatives will do to you? Tab. And let's go change that to 3. Enter. There it is. That looks right because that goes through 0, 2, and 0, -2. All right. So we got it. Let's take a look at this one here. I can already tell my A is going to be negative, and I got 1/2 and 1. That's my H and my K. That's 1/2, and that's 1. And then it looks like we're, and this is what? 1 and 1/2, or 3/2. Let's do it that way, 3/2. And that is 1/2. I hope you like fractions. We're about to play with some. What do we got here? So we got 1/2. 1/2 equals, we don't know what A is, and that's going to be x minus 1/2. I'll say x is 3/2. So we got 3/2 minus 1/2, and then we've got plus 1. 3/2 minus 2/2, which is 1, so we got 1/2 equals A times the square root of 1. I meant to subtract that, so let's subtract that. That's going to make that -1/2. Okay? So, and the square root of 1 is 1, so we got -1/2 equals A. So our equation, g of x equals -1/2 times the square root of x minus 1/2 and then plus 1. Good deal. (18), what does it say here? It says, use a calculator to evaluate the model at the indicated points and connect the points with a curve to complete the graph of the model. Calculate the average rates of change over the first and last intervals and explain what the rate of change represents. Okay. A farmer is trying to determine how much fencing to buy to make a square holding pen with a 6-foot wide gap for a gate. Length of the fencing, F, in feet, as required as a function of A, area, in square feet is given by F of A equals 4 times the square root of A minus 6. Evaluate the function from 20 feet squared to 100 feet squared. Okay. You can put that in the calculator, 20, the square root of 20 times 4 and whatnot, and you'll get well, what do we know? That's going to be down 6, and anyway, 20 feet that's going to give you, let's see, 20 feet. That's going to give you like 11.9, 20, and that's 11.9. I'm using a calculator on the side. And then if you do it at 40, that's going to give you 19.3, 40, and then 19.3, that's probably 20 right there, so I'll put that real close. And then the next one, that would be 60, and that's 25. And I'll just show you what you got 44 times the square root of 40, and then it was minus 6, and yeah, 40, and that gives you 19.3. All right, so that's how that's working. And the 60 gives you 25. We'll say 25 is about right in there. And then 80 is 29.8. So if that's 24, that's 28, 29.8, maybe a little bit bigger. And that's 80 and 29.8. And then the last one is 100, and that's going to give you 34. So 132, 34 is going to be about right in there. And it's going to look something like this right here. I'm not going to put it right at 0 because it went down by 6, remember? So it looks like this. All right, good. Now, first, let's see. Evaluate the function. Okay, by kind of length of the fencing. How much fencing to make a holding pole? So the first interval was 19.3 minus 11.9, and it's 40 minus 20, and that's going to give you 0.37. And then the last interval is going to be the last interval is going to be 34 minus 29.8, and that's going to be 100 minus 80, and you put that in your calculator and you get 0.21. So the rate of change represents the extra fence length required for each additional square foot of the pen area. The rate of change decreases with the increasing area, so the extra feet length needs to decrease as the area decreases. Okay, and that tells you how much you need at each square area. Good job, folks. We will see you in class tomorrow, and you have a nice day.